This is the first in a series of videos I'm going to do about this RCA 10 watt PA amplifier. This is model MI-12161. I haven't been able to find much information on the internet about it, but it does list the tube types here. And it says on the back it's a PA amplifier. And I also found something that it was listed in RCA broadcast audio equipment catalog. So this dates back to about the 1950s, and the tube lineup is very similar to a Fender Deluxe Model 5C3. So I'm going to repurpose it into that along the way in a series of videos. So please like and subscribe if you want to be involved in seeing those. I got this at a Hamfest about 15 years ago. It sat on the shelf. Someone has modified it probably for their ham setup. It says talk, listen, mic cable here. So I'm going to remove that part. I've got tubes in my large tube supply so that I can cover every tube that this has with the used tubes that I have on hand. One thing that's missing is the power transformer. This transformer is the audio transformer, but I found one in my big box of transformers that looks like it'll work. It's about the same size, slightly different footprint, but in particular it has all the voltages that are required for this, and it's also about the same physical size, which tells me it probably supports the power requirements. That's just a guess, but you know, an educated guess. On the back, here's the sticker. Part of it's peeled off, but here's the EMI designation. We've got outputs for different ohms of speakers, and this appears to be a phantom power for a microphone. It has these different ohm outputs, 4, 8, and 16. Nowadays speakers have kind of standardized on 8 ohms, so that really isn't an issue. Here you can see the tube lineup. We've got a pair of 6V6s, which are the output tubes in a push-pull configuration. 5Y3, which is a full-wave rectifier tube. 6 SL7 GT and 6 SJ7. So one of these is the phase splitter for the power output, and one is the preamp for the microphone. I don't know which is which yet, but we'll work that out. This is an extra that I'll show you as we look at the bottom side. Here's something that's an add-on, which appears to be a bridge rectifier of a solid state variety. I'm going to take that out because we're going to be using the 5Y3 full wave rectifier tube. This has a lot of passive components all wired together, which is standard for this era. You know, I don't know what the previous owner did to change this, so we're going to end up ripping parts of this out that don't match the need of the 5C3 Fender amplifier configuration. Some of it will be fine as is, primarily the filament supplies of the tubes. So we've got all 6-volt tubes here except for the 5-volt rectifier, which is pretty standard. So here's some other side connections. This is microphone, and this was originally phones, but they had used this as basically a hole to push another cable through. Got the power cord and things and power switch. That'll get replaced at some point. So here's the plan for the teardown. I'm going to take this extra stuff off. I'm going to leave the power cord intact for now. Do cleanup at some point. The knobs here are generally good. They might be a little bit off kilter. Those need to be cleaned and possibly recentered on their right positions. Then at some point we'll be tearing out whatever isn't needed underneath here. That includes probably this rather terrible mod that the previous owner made, as well as probably all the vintage capacitors The vintage resistors may be fine as is. I'll check the value on those and see if they're in spec relative to the 5C3 schematic. They may be different in a lot of cases involving bias and so on. So we'll have to replace those if they're not the value that's needed in the current design. Here's that rectifier that doesn't have a purpose for us, so that's going to go. So the first thing to do will be to drill out this extension side and then remove the components underneath and clean it all up. Here it is with the first parts removed that I plan to. Here's the bridge rectifier, this plate on the side. Took the parts out of that. This is a switch and relay kind of combined, glued together. We'll do something with that in the junk box. More junk box components, that capacitor that was hanging out. Turns out I drilled these out with a small drill press that I have, and that was fairly easy to do. Now looking at the bottom of this, I haven't made too many changes on the bottom except for those things you saw in the pile. I did test these capacitors individually. These are rated at 50 microfarads and they tested at about 30. I tried to test some of the resistors, but it was hard to get values, I think because they're interacting with the capacitors the way they're wired up. So I'm changing my plan a little bit. It's going to be more trouble to reuse these components than they're worth, plus the fact that they're questionable in terms of if they're still good into the future after already being whatever 70 years old. So aside from the filament wiring and kind of like this is the basic signal ground, we're gonna gut just about all of that. So I'll do that separately and then we'll see the result next. Here's the chassis after I've cleaned out all the passive components. I've got those set up in kind of little piles here. Got carbon comp resistors to be thrown away. I tested these capacitors. These three are all way out of spec. This one is pretty close, but probably discard it. This is a newer one that the previous owner evidently put in, and we'll maybe store that away for some other use. These blue items I was certain were resistors, but they don't test like resistors and they don't even test like capacitors. They're not inductors, obviously, so I'm guessing they're power resistors that are kind of torched out in some way. Maybe they had some sort of overvoltage go through them or something. But our next step in this area will be to basically clean out all these leads that I've kind of left hanging. Here's the unit after I cleaned out all the excess hanging leads and associated solder. I left this center bus bar intact, which resulted in a lot of extra desoldering work, but that looks like a good way to connect the successor design. One other thing I did was make a hole for this transformer to mount inside. It originally had these two holes that you see on the side that were for wire bundles to go through, but since my transformer is missing one face, it made more sense to kind of make a full hole for one side of it and then be able to drop it down in there, and all the high voltages would be enclosed within the case for safety purposes. Here's a pile of solder and miscellaneous that I removed. That's the old-fashioned lead solder, so that's going to have to be properly disposed of. Here's some stuff that was inside the power cord. I ended up having to drill out the inside of that to relieve this mechanical connection, which is the type that's designed to be inserted once and never removed. So you have to kind of eliminate what's inside in order to get it loose without breaking it. It appears to be the old Bakelite that you might have had in the 50s. And here inside was this strange hair stuff, which makes me think of horsehair or something. But if you know of what that kind of stuff was that was used in the 50s in power chords, please let me know in the comments. So that does it for this video. We're going to be looking in the next video in this series at installing the power supply, including the transformer, wiring, filter capacitors, filter resistors, etc. So hope you enjoyed this video. If so, please like and subscribe, and look for part 2. Thanks for watching. Bye bye.